In this lesson, we will use horizontal stretches and compressions to graph a function. For a positive real number a, for a greater than 1, the graph of y equal to f of ax. So the a here, the constant, is multiplied to x. This is obtained by dividing each x coordinate of y equal to f of x by a. The resultant graph is a horizontal compression. Now for a between 0 and 1, the graph of y equal to f of ax is obtained by dividing each x coordinate of y equal to f of x by a. Now, since if a is between 0 and 1, that is actually a fraction. It's like multiplying your x by 1/2, by 1/3, a fraction that is less than 1. So when you divide each coordinate, each of the x coordinate of f of x by a, that also means that you are multiplying the x coordinate of f of x by the reciprocal of a. So for instance, if you're multiplying it by 1/2, if you're dividing it by 1/2, that means you're multiplying it by 2. Now in that case, the resultant graph of the function is a horizontal stretch. To illustrate this, let us consider graphing or using the graph of g of x equal to cube root of x to graph f of x equal to the cube root of 8x. Now recall, the graph of cube root of x look like this. To graph f of x, it will be useful to construct a table. And now for the graph of f of x equal to cube root of 8x, we recognize that this function here is just the same as the function for g of x evaluated at 8x. So this means that this is a horizontal compression because 8 is greater than 1. So our a here, which is 8, that coefficient is greater than 1. That means we have a horizontal compression. Now to see the compression or how this graph will be compressed, let's take a look at this table here. So we consider first points on the graph of g of x, which is the cube root of x. So let's consider points. So that means points on the base function or basic function. So we have this point here, which is 8. So x8, 2. And the point 1, 1. The point 0, 0. So again, these are points on the graph of the base function. This point here, that is -1, -1. And also the point here, which is -8. Oops, it should be -2. Okay, so let me just correct that graph. So it has been corrected. This is -8, -2. Now, for this, we want to see where this point would go when we graph the function f of x equal to cube root of 8x. Now, to see the compression, we will fix the y values. Because if you recall, for a greater than 1, the graph of f of ax is obtained by dividing each coordinate of the base function by a. So we will apply that here. We will divide each of the x coordinate here by the factor here, or by 8. And then all the y coordinate remains the same. So this point here will now go to, it will go to 1, 2. And this divided by 8 is 1/8. And then you keep 1. The 0 divided by 8 is a 0, so that remains 0, 0. Now, -1 divided by 8 is -1/8. You keep the -1, the y coordinate. And here, divide this by 8 as well. Or you have -1, -2. Then we plot these points here to the Cartesian coordinate plane and see that, and then we would see the compression. Right, so let's plot these points here. So first, let's have this 0, 0 will remain 0, 0, so it will stay here. And then the point 1, 1 goes to 1, 8, 1. So the y coordinate is still 1, but the x coordinate now becomes 1, 8. So it goes here, very close to 0. You just approximate it. Then this 8, 2 goes to 1, 2. 1, 2. So it goes here. And then this -1, -1 goes to -1, 8, -1. So -1, 8, -1 is here. Really close to 0. Then -8, 2, this point here will then go to -1, 2. So it goes here. So as you see here, this was compressed. So like this point goes here, the point here goes here, this point goes here, and the point here goes here. So the graph of this function, okay, we would have to then just trace. It would look like this. So you see how the graph is now compressed. Now, upon examining the points here, we recognize that there is a horizontal compression. So therefore, we conclude that there is a horizontal compression, or sometimes we use shrink synonymously to compression, or there's a horizontal shrink by a factor of in this case 1/8. So again, from 8 becomes 1, from 1 becomes 1/8. So it is by a factor of 1/8. Now for the next example here, we want to see the effect of the factor here 1/8 to the graph of the base function, cube root of x. So we use that same base function and recall that the graph of cube root of x is this function. Now to see the graph here in relation to the graph here, we will consider points on the graph of the base function. So we have g of x equal to the cube root of x as our base function. And again, we look at those same points. So the point 8, 2, 1, 1, 0, 0, -1, -1, and -8, -2. And then we take a look at where these points would correspond to the function f of x equal to cube root of 1/8x. Now recall, for a between 0 and 1, so in our case a is 1/8, so that's between 0 and 1. The graph of y equal to f of ax is obtained by dividing each x coordinate of y equal to f of x by that factor a. And the result of the graph will be a horizontal stretch. Now let's apply that to the example here. So our x coordinate will be divided by the factor here. So here we have 8 divided by 1/8. 8 divided by 1/8 is equal to 64. And then you retain the y coordinate too. 1 divided by 1/8 is equal to 8. Retain the y coordinate. 0 divided by 1/8 is still 0, so 0, 0. And then -1 divided by 1/8 is -8. So you can verify that using your calculator. Now -8 divided by 1/8 is equal to -64. Now here, oh, this is -1. Now if you look at the new points that correspond to each of the points that we consider, the point here, this point, that point, we notice that this one here will go to 64, so 8, 2 will go to 64 too. So we have a horizontal stretch. So this graph here will be stretched horizontally by a factor of 8, because from 8 it goes to 64. From 1 goes to 8. You look at the x coordinate. From -1 goes to -8, and from -8 it goes to -64. So the graph of the new function would be the graph that you would be able to determine by just plotting these points here. So let's take a look at this point. So 64 is no longer on that window. So let's just do 8, 1. So this 1, 1 here, 1, 1 will go to 8, 1. So it will go here to 8, 1. Then we have 0, 0. And then the negative. See this -1, 1, -1 will go here. So this graph here was stretched. So it will go like that. All right, so as you see here, the graph is stretched. This original, the base function was stretched by a factor of 8. So horizontally stretched by a factor of 8. So before we end this lesson, I wanted you to take a look at the relationship. So this is 1/8. F of x equal to cube root of 1/8x, but that means that this graph is stretched by a factor of the reciprocal of this number. And from the other example, since this is cube root of square root of 8, this is a whole number. This means we have a compression or a shrink by a factor of 1/8. And that 1/8 is the reciprocal of the number here. So for horizontal, the factor is the reciprocal of a.